Welcome back to the second in the series of t-tests. What you see on the screen right now again is the data set for the for assignment number 3, and you can see the gender is highlighted. In the last video, you may recall we did a t-test in which we showed the following. We showed that males were higher in their alcohol consumption than were females, and we found that that was a statistically significant difference. Now I would like to go back just to alter this just slightly. I'm going to go back to and reanalyze these data. I'm going to compare means. Cancel. I'm going to analyze, compare means, go to the independent samples t-test. Now there's been some question raised in the class about how to define the groups. This 1 and 2 that I put in here is completely arbitrary, except that the males and females have to be coded as 1 and 2. So if we put in a 0, that wouldn't work, but the order makes a slight difference. Let me just change this and make this a 2 and a 1. Now some of you are going to be thinking ahead and realizing it's just going to change the difference. It's going to put females first and males second, so it's going to change the order of the subtraction that takes place in the numerator of the t-test. So let's just continue, and so let's just see what happens here. I'm sorry, I got a little confused there, excuse me. So in the previous, what we found was that males were at 13.93 and females were at 10.9. Now we run it again. This is the new analysis, and we find that females are 10.9, but it's just changed the order. So in the numerator of the t-test, it's subtracting the male value from the female value in this test, just because we've changed the order of the coding, and we see the t is the same value. It's 9.627. Here it's 9.627. It's just negative, and it's kind of arbitrary whether we put females first or males first. Everything else stays the same. The degrees of freedom are the same, the p-value is the same, and so forth. So that's just sort of an arbitrary decision that we made to put males first and females second. So I hope that's clear for you. If we just scroll between the two results, we see that in fact what I can do, I believe, is I can cut down a little bit on the notes, and we can put those actually kind of side by side. So here we see the t-tests are identical, except that we have a negative sign, and all we've done is we've reversed the order of the terms in the numerator for the t-test formula, and that's all. Now one thing I like to do is, when I'm doing a lot of analysis, is clear out my output page every once in a while, so I don't have a lot of stuff to look through. So I can click here. It's going to ask me if I want to save the contents. I'm going to say no, and it just throws away that output. Some people print their output, some people save their output and refer back to it later, but I tend to just throw it away. Now I want to do one thing with recoding. I assume I'm going to have about 3 or 4 of these videos, and I like to keep them around 5 or 6 minutes each. Okay. So yesterday in class we looked at what do we do when we want to compare 2 groups with a t-test, but we have more than 2 groups. So there are a couple ways of doing it. Let me show you. Let's pick a potential independent variable here. Let's look at race. If we do a frequency distribution of our racial categories, just with descriptive statistics, Let's get rid of gender, and race should be close by. Now here we see we have white, black, Asian, Hispanic, other. And suppose we're just interested perhaps in comparing Asians and Hispanics, for instance. As a matter of fact, one of the students working on this study a long time ago, working on her master's thesis, just looked at Asians versus Hispanics in her study. So how would we do that? Well, there are a couple ways we can do this. Let's first just see if we can do a t-test just like we did before. Now we're going to look at the difference between Asians and Hispanics on this alcohol total. Now I'm thinking that there's not going to be any difference between Asians and Hispanics, but let's just take a look at how we might do that. I'm going to go to my Analyze. I'm going to compare means. I'm going to use an independent samples t-test. Let's just stay with the same dependent variable, but we're going to get rid of the gender, and we're going to come down here to race. And you should be saying, but wait a minute, stop, Dr. Dudley, you can't do that because there are 5 categories of race. Well, because I can define the groups, I can just say only focus on Asians and Hispanics just by doing this. I can define the groups as 3 and 4. And it will exclude all the other groups. It won't delete them from the database, but it'll just only focus on race differences between Asian and Hispanics on alcohol total. Let me just run this and see what happens. Okay, so here we see that Asians have an alcohol total of 12.17 and that Hispanics have a total of 13.6. So in this study, also notice we have very few in the study, only 73 Asians and 47 Hispanics. So is that a significant difference? Well, a couple things are happening here. If we just go down to our t, we see that it's small, it's less than 2, and when a t becomes less than 2, we know that we're going to have a little chance of rejecting the null hypothesis. The degrees of freedom are 118, and that basically is arrived at by adding these two values together and subtracting 2. But here's our p-value. So let me scoot this over a little bit, make sure everybody's seeing the same thing. So just as I would in class, I'm going to ask you, and in the privacy of your home right now, you can respond, would we reject or fail to reject the null hypothesis? The null hypothesis being that the two groups are equal. I'm waiting the prerequisite 6 seconds here. Your answer should be no, we cannot reject the null hypothesis because the p-value, which is called significance value here, is greater than 0.05. So even though we see that there's some difference between Asians and Hispanics, with Hispanic students showing somewhat higher alcohol consumption, this is not a statistically significant difference. Okay. So let's stop there and go to our next way of looking at t-tests.